I'm Ellis. I'm a product manager working on Forma. My background is actually in mechanical engineering, but I basically abandoned that as soon as I got my degree. I started at Spacemaker back when it was a startup before we were acquired by Autodesk as a data scientist, and then sort of realized that I was more interested in kind of product strategy, and I really enjoyed sort of talking to users and understanding where the needs were and sort of translating some of that technical stuff into things everybody could understand. So I'm now, I've worked on a lot of the sustainability features in Forma, our microclimate analysis, our solar panel analysis, and I'm now focused mostly on bringing sort of this early stage carbon prediction into Forma.
Okay, great, awesome. Ian, you're up.
Yeah, thanks, David. Yeah, Ian Molloy. I am one of the product managers with the Autodesk building group that looks after Revit. And so I look after essentially the sustainable design features in Revit, known as Insight, and also everything Revit MEP from design through fabrication. My background is actually in mechanical engineering and building science.
Oh.
I have been involved in software development and sustainable design consulting, and the convergence of those two is pretty much my whole career. And based in Boston, been with Autodesk almost 14 years now.
Wow.
And like Ellis, very interested in the intersection of the industry and customer and user needs and what software can do to solve those problems. That in itself, the art of product management is a very interesting domain.
Yeah.
And I love to be able to do it in the domain that we do with AEC and sustainable design. It's awesome.
Yeah, awesome. I mean, in the largest sense, if the architects don't have the right tools, it's hard for us to make an impact in the way that we keep wanting to make or keep talking about. So we're pretty excited to hear what you guys have to say. So this recording is a little bit different, as people know, because there's going to be a presentation component, which we're going to ask a bunch of questions throughout, a bunch of dumb questions, I'm sure, which you guys will appreciate coming from us. But so I think we're going to start with learning a bit more about Forma.
Yeah. So we do have to start, because Ian and I are both on the product team, by saying that in order for us to talk about stuff that's in active development, that's forward-looking, please don't make any financial decisions based on content of this presentation. So really exciting way to kick it off.
Understandable, though.
Yeah, disclaimer, yeah.
Yeah.
We might have to start saying that on a long recording for ourselves.
Yeah. Let me try at least to share my screen here.
Perfect.
So I'm going to start with some context about Forma, because kind of everybody knows what Revit is, but Forma as a product is only like a year and a half old.
Mm-hmm.
So I'm going to start by saying, kind of Forma's primary goal is to enable what we call outcome-based design. So bringing those outcomes, what you're seeing here is a sun, noise, wind, solar panel potential outcomes to the beginning of the design process, to make those available with little to no technical training.
Okay, gotcha. And so if I'm an architect, I would use this Forma is a standalone software. It's a web-based software.
Yeah, so Forma is standalone. It is fully cloud-based, which means you don't have to download anything. It also means that sort of as we update the software, as we make improvements, those are automatically in the product you're using without having to download anything new.
Mm-hmm.
So it's also stuff like, if you're collaborating on a project and you make a change, you don't have to send any files back and forth. It's all already there in the cloud.
Gotcha. And what would be some use cases? So, as you know, a lot of our listeners are architects. If I'm an architect, for what types of projects and situations would I use Forma? Is it for a particular project type, a scale of projects, things like this?
Yeah, so, I mean, Forma is useful across a lot of different types of projects. I think sort of anywhere that you're interested in seeing these type of outcomes from the early stages of design. A lot of them do lend themselves really nicely to sort of larger projects where you're looking to see these type of conditions on a site rather than on a single family home, something like that.
Yeah.
Sure.
It kind of makes sense. I mean, the impact and the amount of facade and things like that is much greater on multi-stories versus single family.
Okay, gotcha. And if I'm not mistaken, one of the ideas with Forma is that it would allow me, an lead architect, to kind of quickly see this information almost from the very beginning. Is that?
Yeah, I think a lot of sort of the challenge that we try to tackle that I think is really interesting is especially in these early planning stages of design, architects don't have a ton of time. You're often not actually paid for these parts. This is like before you've won a project.
Gotcha.
And so making this sort of fit as easily as possible into existing workflows is really important. It's really hard to get people to use a new software if it has a steep learning curve.
True.
And so our goal is that all of these come really easily with sort of basically no technical training required.
Gotcha. Okay, perfect.
We can take a step back and sort of go through how you set up a project in Forma.
Yeah.
Which I think sort of illustrates hopefully how quick and easy a lot of that stuff is.
Yeah.
If you guys want to, you can give me an address and we can set up a site there. I'm also happy to not put you on the spot and start with one of my own.
Let's start with one of your own, because I'm either going to name a previous employer, which would not be
yeah,
or I'm going to name someone's house.
Right. It's suddenly hard to think of any other address.
Yeah, 100%. Yeah.
Okay, so
it's like the Eiffel Tower.
This is the site next to the Eiffel Tower. I'm
sure
is it? It is.
Okay.
Yeah, it's sort of not precious at all to the people of Paris or French people. I think it shouldn't be an issue for us for me, a non-architect, to throw some buildings on a site here without offending anyone.
Well, Marina is French, so you've won some brownie points.
But I'm not from Paris, so...
Okay.
Yeah, you might be more anti-Parisian than the rest of us, I guess.
That's a good assumption.
I won't say on camera, but...
Like I said, it's fully cloud-based. It takes a few seconds here to sort of set up your site. And it comes, because every project in Forma is geolocated, it comes with sort of a lot of easy contextual data. So you'll see this terrain data has already been automatically added. I'm going to use this surrounding existing building data from the French government. You'll see this just takes a few seconds to load over here, and then we can place that in the canvas. And we sort of think that already that provides sort of a lot of value to, within 45 seconds or something, have a lot of this contextual data available to you.
Oh, cool.
Well, so what we're looking at for the folks who are listening is you were logged into an Autodesk Forma, basically a website, just in a browser, right? And then you just punched in an address and it zoomed in, kind of like Google Maps, onto the location. And now we're seeing a 3D aerial view of what looks to be 3D massings of buildings, including the Eiffel Tower, which is pretty remarkable.
Yeah, so all of this contextual data is editable. You can also sort of, if you want, you can use Forma just to set up a site and then move all of this into Revit or somewhere else.
Cool.
I mentioned that this data is from the French government. listeners can't see this. This is the ugliest Eiffel Tower you can possibly imagine. I wouldn't maybe put that in like a final important presentation, but it's good enough to understand some of those outcomes that we were talking about.
Fascinating. And so you had mentioned it a second ago, but the sets of information that come with the site without having to do any work are the terrain and a few other things. Obviously the buildings, the adjacent buildings.
Yeah, sort of the surrounding existing buildings. And you'll see here, these are sort of a low level of detail, the stuff that kind of comes automatically. I'm going to, in a second, take us to a different site where you can see a lot more detail has been added to those by bringing them in from somewhere else. Forma has sort of native drawing tools, and you can see they're sort of creating basic massing models. I am not an architect, and I'm not going to embarrass myself by trying to create a nice looking site here for you guys. So I'm actually going to switch to one that somebody else at Forma has
I was excited to see where we're going with that.
Yeah. Unfortunately, I think I'm going to skip that part today. You can see here, these are sort of massing models. You are able to get more detailed buildings drawn natively in Forma. You can see here, this one has a lot more detail on the facades, has like shading, sort of all of that sort of stuff. And remind me if I'm sort of leaving too much to the imagination of the listeners.
No, this is working so far. So I guess one question would be, so you can do some basic and pretty decent modeling within Forma. And what is basically, it feels like from an outsider's perspective, is we're modeling within a Google Earth sort of, but it's Autodesk format. Are we also able to import work from other softwares into it, or does Forma be imported and plugged into Revit, or how does that relationship work with other 3D modeling programs?
Yeah, so you absolutely can bring in stuff from other places, from Revit, Rhino, SketchUp, sort of wherever. And some of those models, like here, will be editable in Forma. You can not only sort of see all of these outcomes around them, but actually change them once you've brought them in. Some other ones are sort of, they import just as a mesh, and so they're not editable in Forma, but the wind analysis, all of that stuff will still work on them.
Amazing. And so in getting a bit more detailed with that than into the nuts and bolts, so from Revit, let's say, am I exporting from Revit a certain file type and then uploading it to the Forma website?
So actually between Revit, and I believe there's you can do it with Rhino, there's sort of more of a live link where you can bring it in and make edits that are immediately reflected between them.
Oh, I see. So it's kind
in
of...
other cases, it is more like you bring in a specific file.
Gotcha. So in the use cases of Revit and Rhino, like you were talking about, it's sort of like a linked file. Yeah. So
yeah.
Okay.
Exactly.
Interesting.
Once you have whatever sort of buildings and geometry you want in Forma, we then have all of these analyses, which are sort of more related to the rest of what Ian and I are going to talk about today. So you can see stuff like these area metrics. You can see sun hours. And again, because the project is geolocated, we can sort of like sun path, all of that stuff is automatically there. All you have to do is put the dates that you're interested in.
Gotcha. And then wind also.
Yeah, and then I think wind is sort of an interesting case here because the wind analysis is a full computational fluid dynamics wind simulation. And so like physics-based, as you can see, it takes a while. It takes like an hour.
Okay.
But Forma also has these AI-based analyses that can predict the results of wind and noise, these analyses that take a little bit longer, in about a second. And so that's what we're looking at right now, you can see if I quickly draw a new building on the site, it takes about a second for this analysis to update. So you can sort of work more iteratively if wind or noise is an outcome that you're really concerned about.
That's crazy. So for the full analysis, it takes about an hour or so, probably depending on the complexity of things. But did you say there's an AI? It's an AI-based predictive model that allows it to spit out a pretty good guess within a second?
Yeah, that's exactly right. So it's
Weird.
trained on the results of that full physics-based simulation. And so it's actually just predicting the results of that.
With the changes.
Yeah.
Okay, gotcha. Interesting.
The last thing that I'll talk about sort of in this general Forma demo is this, what's called Forma Board, which is sort of a mural-esque thing. And it lets you put all of those outcomes in one place. So you can see these are like live links to a bunch of these analysis results, stuff like annotating images either from Forma or from anywhere else, leaving notes for people you're collaborating with. The last part of this is that Forma is actually also, in addition to those native analyses that the product team has built, is an open ecosystem. So there's a bunch of extensions that have been made by third parties, TestFit, some other ones. And one of them is here, Varus, which is like an AI image generator that you can use the geometry you've created in addition to like, some word prompts to really quickly generate sort of a lot of different ideas, visions of what this would end up looking like.
Yeah, so basically it's taking the model and producing about 6, I guess, different versions of the rendering. So there's like a couple hand sketch versions, 2 different variations of watercolors and 2 different variations on a realistic rendering. Huh, okay.
Yeah. Yeah, and so we think that's really sort of useful for these early ideation stages where you're just trying to throw a bunch of different ideas up there and really quickly understand kind of what they'll end up looking like.
Gotcha. And just as a sort of a recap, so the different metrics that come out of it are, we have the sun, the wind, and...
So there's, sun, there's sort of sky access, wind, microclimate. Go
sky
ahead.
access means like access to daylight?
Yes, although I think it's important to clarify that like this is not interior daylight. This is like what percentage of the sky does this have access to? Interesting.
Okay.
Yeah.
And wind, and then what's microclimate?
So microclimate is like an outdoor thermal comfort. So it combines the wind, sun, with local weather data. Again, that's sort of automatically sourced to tell you sort of the feels like temperature around your site.
And is that for the entire site, or do you pick a point on there and say, if I have a balcony facing west, what is that going to feel like?
So it is for the entire site. So you can, let's see if I can pull it up quickly, but you can sort of tell it what part of the site you are most interested in.
Gotcha. I guess my question is basically, it's not a generic metric applied across, like the site you're showing us is quite large. It's like 4 blocks or 3 blocks by 3 blocks. So it's not a generic, I mean, it'll vary depending on what side of the site we're on, and for sure with the winds and whatnot.
Right. Yeah, and so you can see it on the right here. It sort of reflects a lot of the shading. It reflects a lot of if a courtyard is shielded from wind, stuff like that.
Right, and this is based on the time of the day, the January, the season, and it's showing us the air temperature, the wind, and there's very bright colors. Blue presumably means colder.
Yeah, and so you can sort of click around and see that in January, this part of the site feels like -3. It probably has some bad wind conditions or something like that. It maybe is not such a nice place to walk around. But in this courtyard we've created, it's actually closer to 10 degrees and would be a lot more comfortable even in the winter.
Yeah.
Do you get like kind of like a report, maybe more like overall in percentage, let's say, of like how efficient, the project is? Because graphically we can see, okay, well, the roofs are going to be not so great, but, maybe we're talking about like, I don't know, 30% of the project. If we tweak that, then we're like closer to like a 20, 70% efficiency. Yeah, okay, you have a little breakdown.
Yeah, so a lot of them come with these sort of stats. This one lets you see sort of what percent of your site is falling into each of those categories. So here you can see like actually not too much of the ground, at least, is in these really cold temperatures. Most of it is a little bit more comfortable.
And this, what we're looking at, is for the microclimate section.
Right.
Could we take a look? And I'm very curious just to go through all of them and see what they each look like.
So
this is very different from what I learned in school when we were doing windrows diagrams with like what felt like Crayolas, which was so primitive. It's like, and then everyone would ignore it after the first 2 weeks. It's like you lose the piece of paper and you're like, whatever. Okay, so now we've seen the sun.
So here's the sun.
And we're actually doing both side by side, in fact. Yeah,
I think that's a sort of important note, especially even as we get deeper into what we're talking about with carbon, stuff like that, that like we're really focused on hopefully enabling people to create more sustainable sites and designs. But that's not just one thing. Like sustainability doesn't just mean carbon even. It means successfully balancing all of these different things.
Yeah, for sure. What about, it just occurred to me, I assume the green cylinder things represent trees. So what about landscape features like trees, hedges, sloped topography, if those can be added into the model, and do trees have an impact on what the model produces?
That is a really good question. So we have received a lot of, let's say, not praise for how the trees look in Forma right now.
They
look like little marshmallows, little green marshmallows.
Yeah. It would probably be better if they looked like trees, but part of the issue is that they do affect the analyses. So they affect the wind analysis, stuff like that, which makes it a little bit trickier to sort of model actual things that look like trees. I think a lot of that sort of landscaping, that like terrain editing that's really important in these stages of design is something that we're working on improving in Forma. Gotcha. So there's some of it right now, but it's coming in the next, well, I guess I can't give any timelines, but it's something we're actively working on. Yeah,
trees are brutal.
Tough.
Go ahead.
Go ahead.
I was going to ask also, what about things like materials like asphalt versus grass?
That's a really good question. So that's actually sort of another thing that is in the works. I think it's sort of the microclimate analysis as it is. We think it's valuable, but a really important part of like urban heat islands is that the effects of surface materials. And so that's another thing that we're sort of actively working on adding. And you're going to see some of those sort of material definition things are also a big part, obviously, of everything carbon.
Yeah. I was going to ask too, like, right now we're looking at more like, let's say, conceptual massing primitive models. Is there a limitation to how detailed the model that can be imported in or linked to Forma be? Meaning to say, can you import a model that's like, well into CDs, that has a lot of details on the facade, and does that impact those analysis or not so much?
So you can bring in very detailed models, but right now Forma sort of won't understand any of the interiors of them. It can import sort of any detail level as a mesh, and then that, some of these analyses are still really useful with that. You can see sun and wind and noise and stuff like that. When we get to carbon, that sort of is where those limitations start to arise more.
Okay. Interesting. Yeah, I can see, like what you were saying earlier, a really good use case is when, our architecture office is doing our larger scale project would be maybe a more common use case. And we're having to put together some rough massing ideas of where we want to locate the building stuff on the site. Do we do one giant tower at the north? Do we do 4 blocks? Do we do 3 blocks? Is it this kind of thinking, and having a very quick understanding of like the environmental impacts that we're having and how much sun we're getting. This feels like the playground that we would be in with this tool.
Yeah, I think that's exactly the kind of use case that we're aiming for right now. And then, like I said, since it's a cloud-based software, it makes it a lot easier for us on the product team to sort of update it as we go. And so things like more detailed buildings, better terrain editing features sort of can be continuously pushed and improved.
Gotcha. And then going back, so running through the list, so we also have noise, which is super fascinating.
Yeah, how do you get the information for noise? I mean, you have people on the ground who are like recording with giant microphones. Like, how do you put that information from? That's fascinating.
So that actually, you as a user do have to add those noise sources. We've tried and tried again to get them automatically added, and it's really difficult, unfortunately. Yeah. And so you have to define, like, here's a road, here's the traffic on that road. And a lot of that information is actually a little bit easier to find than you might think, but it still does have to be user added.
No, that makes sense.
And then from there, this is like a full physics-based simulation of sort of how noise travels across the site, how it bounces off buildings, stuff like that.
Very cool. For the context, I guess, model, is there a limitation geographically as to where that information is available or not available? Like if I have a project, I don't know, you're
gonna choose some weird place
in the middle of the desert, or like whatever place. Is it fairly easy for people to find the information they need for the buildings, or is it mostly like I don't know, big cities versus smaller towns?
I think we have at least sort of basic building information for most places. I won't guarantee that it's everywhere. I think it's also possible that it's like a little more out of date in some places. Sure. So sort of if you know the site well, it might be a good idea to sanity check it. But I think a lot of the terrain sort of is there almost no matter where you are. I know I saw a user was creating a site on top of Mount Everest for some reason, and that worked. I mean, I don't think it got built, but you were able to model it.
Wow.
That's someone who's used to playing Minecraft or something, and they just want to
yes.
And then other metrics we have on the left. So on the left-hand side, there's a panel, and area metrics, I think, is the first one, if my eyes are so interesting.
Yeah, so, right. I mean, this is sort of recognizing that there are constraints beyond these environmental impacts. Uh-huh. So letting you see the floor area, letting you filter it by building, sort of basic stuff like that. You're able to tag buildings and parts of buildings as different functions, that kind of thing, that help you understand the divisions between the floor area.
Are you able to save those specific, time frame and seasons to be able to toggle back and forth and come back if you've made revision to the model?
Save it as a snapshot, sort of.
Yeah.
Yeah.
So what we're looking at right now is sort of different outcomes from the same site setup.
Yeah.
But you're also able to compare between different site setups. You can compare different sun analyses for different dates, all of that sort of stuff.
Area metrics, wind. My vision's not very good. What does it say, Marina?
Let's see. I think we've touched on all of them over here. We haven't looked at daylight potential, if you guys want to see that.
Yeah.
Oh, you can see. since I ran this analysis, we've released a new version that includes statistics. So that, okay, it was a few months. But you can see basically what it's showing here, which is how much exposure each point on the building, facade, roof, how much access that has to the sky.
Interesting. And then maybe to one of Marina's earlier questions, is it possible to like export this information as a PDF with images and text, or is it an Excel file, or is it the board that you were describing earlier?
Yeah, so the board will be the best place to export sort of, if you're looking for like a PDF or something like that. I think we are working on creating better exports for like the analysis stats that you're seeing in here, where you could automate creating a report or automate creating something that would fit really easily into a PDF that you're sending to a client or a municipality or something like that.
Gotcha. Yeah, I could see where when I would be working, I would have, if I have the two linked or even not, I'd have one monitor with this and then another monitor with the model, or maybe just work in Forma, just have the two side by side. So as I'm making tweaks, I can see the impact of what I'm doing more or less in real time, actually.
Mm-hmm. Yeah.
Incredible.
If you have any other questions about sort of Forma generally, I'm happy to answer them. Otherwise, I can jump into more of the carbon specific stuff.
Yeah, let's jump into the carbon stuff.
Okay, cool. So I'm going to start with sort of some basic information about calculating carbon of buildings, just so we're all on the same
That's appreciated. Yeah,
okay.
that would be appreciated. So yeah, let's do that.
Cool. So generally, we divide a building's carbon footprint into two categories: embodied carbon and operational carbon.
Just real quick, Ellis, are we meant to be still looking at the Forma screen?
No, thank you. Okay, I think it should be good now.
Yep.
Okay, yeah, gotcha.
So, we divide a building's carbon footprint into embodied and operational carbon, where embodied carbon is all the carbon resulting from building materials, the production, transportation, construction of building materials.
Gotcha.
And operational carbon is the carbon that comes from operating the building: lighting, heating, cooling, plug load, all of that.
Mm-hmm.
I'm going to focus mostly on embodied carbon. Okay. So Ian will touch more on the operational side of this.
Okay.
So for embodied carbon, the equation for calculating it is actually fairly straightforward. You need a building's bill of materials, so how much of each material is used.
Mm-hmm. And
then you need each of those materials' carbon intensity. So how much carbon is emitted per unit of that material.
Okay.
And then you multiply those together.
Oh, okay.
And so very quickly, carbon is generally measured using kilograms of carbon dioxide equivalent because there are other emissions than carbon that act as greenhouse gases.
Mm-hmm.
So 1 kilogram of methane has about as much global warming potential as 25 kilograms of carbon dioxide.
So when we talk about kilograms of CO2 equivalent, that's including other things beyond carbon dioxide.
Exactly.
Okay.
And so we say carbon footprint, but really this is just sort of the unit used to measure all of that.
Gotcha.
Okay.
Not just carbon. Okay.
Right. Embodied carbon is the carbon from building materials. And if you have a fully modeled building, that first side of that equation, material quantities, is reasonably straightforward.
Mm-hmm.
But a lot of natively drawn Forma geometry is basically massing models.
Sure.
So they're missing a lot of that information that you need to get to a bill of materials. So basically the data availability on a project is pretty slim at the beginning. But
Yeah.
that's when you're making a lot of these really fundamental decisions about the building. It's, basic form, it's primary materials, and those decisions have this enormous impact on its carbon footprint.
True.
We have partnered with a team called C-Scale that came out of EHDD architecture, and they've created an engine for early stage carbon assessment.
Okay.
And that uses machine learning to basically predict your building's bill of materials from the earliest stages of design.
Interesting.
Often, there are sort of two approaches that are used to make that leap from early design to embodied carbon.
Mm-hmm.
You either will use very rough rules of thumb, baselines, or you can use bottom-up generative design. But go ahead.
I was just going to ask, what do you mean? What's the difference between the two?
So the first is sort of saying like concrete buildings usually have something like 500 kilograms of CO2 equivalent per meter squared of floor area.
Mm-hmm.
That's a useful way to set sort of broad goals for a project.
Mm-hmm.
But it doesn't help very much with understanding stuff like, can I save some carbon by making 3 smaller buildings instead of a larger one, or by chopping off a couple stories, making it shorter, but adding a little bit to its footprint.
Mm-hmm. Mm-hmm. Mm-hmm.
And then generative design is sort of taking that massing model and fully generating a structural system for it.
Gotcha.
Which not only sounds very impressive, but is very impressive. But the issue with it is that it generates sort of an idealized building.
Right. Gotcha.
And so it underestimates a lot of those material quantities because real buildings are messy.
Gotcha. Yeah. Where the rough guess probably generally overestimates or is extremely rough. Okay.
Yeah, right. And so we think that that's the advantage of this predictive machine learning model, is that it has learned on real completed designs and real completed buildings. And so it sort of has a lot of that messiness baked in.
I see. So you're kind of combining the best of both worlds.
Yeah, I think that there are still advantages to generative design, that, it can be useful to actually see the structural system that you might be using.
Mm-hmm.
But there are also definitely disadvantages of it.
Interesting.
So by using this model, we can predict the resulting bill of materials from day one based on the material quantities of other real similar buildings.
So I might be jumping ahead, but so how does that prediction take place? Would I punch in, this is office building made of concrete, or I don't know, is there a selection of building types I choose from, or? You've
sort of read my mind again the second time to get like a little bit deeper into the model.
Okay.
What we're trying to drive home, sort of, not just with this, but with our other machine learning features, and I think what's sort of a really interesting question beyond Forma is how you can understand how to use a machine learning model or feature without having to understand how, say, like a neural network works. Like,
that would be nice.
Sure.
Yeah, right. Like most people who are using these or who are using ChatGPT or whatever, if you're required to understand the real innards of that model to know how to use it well, almost nobody's going to be able to use it.
Yeah.
Generally, what we think is that the best way to do that is to understand what the model understands about your model. So here that means knowing that it's taking your building's floor area and height and number of stories and basic structural system and primary use into account.
Interesting. So basically, we just punch in. We're actually looking at it in the presentation, just a dialog box, presumably a screenshot from a part of a computer screen. You punch in the postal code, the location, the structural system. When the example is reinforced concrete, the use of the building, which in this case is multifamily housing. Then you enter in the number of above ground floors and area per above ground floor, and then it takes that information and generates a model of sorts. I mean, not necessarily a physical, a 3D model, but a numbers model.
Yeah, exactly. And so actually what we're looking at here is a screenshot from the web app that the C-Scale team made.
Okay.
And sort of what we see as the symbiosis of this partnership is that we're able to take a lot of that geometric information directly from your Forma model and then just ask you for a few additional building parameters.
Gotcha.
You know, what's equally important to understand with what it is taking into account is what it is not. And so that's stuff like this model doesn't know if you've created a building with a huge cantilever.
Sure.
Or something else that requires sort of an idiosyncratic structural solution.
Sure.
Sort of generally speaking, it's really good at predicting typical buildings because that's where the most data is available for it to learn from.
Yeah. But
it's not as good at like, you know, 85-story skyscraper or single family homes where they're like, it's really, you know, each one is a truly individual solution.
Yep. Understood.
You know, I guess sort of going back to Ian and my intro, I think a lot of what drives us is talking to practitioners. And so we spent a lot of time specifically working with practitioners from Stantec, but also from a bunch of other places, and understanding sort of the difficulties in incorporating embodied carbon analysis into existing workflows. And what we found was that it kind of comes down to it needs to be accessible to people who are not experts in carbon, and definitely people who are not experts in machine learning.
Yeah.
To bring it back to Forma, by asking users for a few primary material inputs, a cladding system, a basic structural system, we were able to add enough detail to these massing models to start making sort of actionable predictions for the resulting bill of materials. So, okay, I've sort of talked through one half of the embodied carbon problem here, how you get to that bill of materials. This part, don't worry, it's not half of what I'm saying, but half of the problem.
Yeah, half of the problem, I got it.
You predicted a bill of materials. What do you multiply that bill of materials by? And I think that this is a really important distinction between what we see as a use case for Forma and what Ian is going to talk about with Insight and Revit. If you're evaluating embodied carbon later in design, you'll want to use product-specific carbon intensity values. Because concrete from over here uses different processes than concrete from over here. And so they emit different amounts of carbon in its production and whatever else. But we think that when you're using Forma, you're more likely trying to experiment with a bunch of different ideas and sort of quickly and easily understand those basic relative differences.
Yep.
And so rather than asking you to pick a specific carbon intensity value, we're sampling from the middle of regionally specific ranges for you. And so again, sort of that data is automatically filled in. It's good to sort of make clear that this is a sacrifice that we've made in some ways. Like we've sacrificed some of the transparency and customizability that Ian is going to talk about in favor of adding as much ease of use and accessibility as we could for an earlier stage of design.
Gotcha. It's an interesting thing. All the conversation so far is because it our office, we mostly do single family houses, which is generally at a much smaller scale, obviously, than the site plan that we were looking at a moment ago. But I think even for us and for architects certainly practicing at a bigger scale, it's always this challenge of I think you had the phrase actionable predictions. What was it? Actionable. Mm-hmm. Yeah, and I really like
actionable predictions.
Prediction. That's a really, really good phrase, because that is really the challenge of that graph you were showing. At the very beginning, you're doing like loose sketches and ideas, and you're ideating, but you're making also really, really big decisions that kind of set the direction of the project from a design standpoint, aesthetically, let's say, but also design in terms of the carbon and the energy and the wind and the solar and all of these things. And it's always the chicken or the egg when you're designing a building or a site plan. It's you need some information to do something, but you need to do something to have information, and it's always just like it's so difficult. And this also reminds me of that, even the budget for projects, like how much is going to cost? Well, what are we building? Well, how, I don't know, because what are we building to know? And it's the same thing also with this information you're talking about. So I can certainly understand why you would want a software to be like easy to use and have kind of like the typical basics in there, so you can start, and instead of having it become too cumbersome and have 100 questions you have to answer before you get to a quick answer, when you're at the very beginning of that graph you're showing at the very first start, where you don't have a lot of information. So it's an interesting, I can see where from the software side it would be an interesting task to like decide, okay, where do we cut off this point of too much input is not good for this portion of this phase of the project, and too little is too little. It's a tough one.
Yeah. I mean, it's exactly right, and it's how do you get these outcomes with giving us sort of the minimum amount of information? And I think like we're probably getting to a point, speaking more broadly than architecture software, where sort of machine learning has become, or AI has become like a hammer, and so everything looks like a nail. But I think that this sort of like, how do we fill in all of these gaps at the beginning, actually is a really useful place for it, as long as we're successfully communicating the assumptions and the understanding that model is working with.
Yep, totally.
So, okay, then I'm going to jump back to give a quick demo of the embodied carbon analysis itself. And I think this is also going to be an interesting point of distinction between what I'm showing and what Ian is showing, because my demo is not going to take very long.
Okay.
Our guiding principle here was to make this analysis accessible, to really lower the barrier to entry. And so you'll see on our screen here, we're looking at the site with some basic massing models on it. I've gone into the embodied carbon analysis on the right-hand side here. And then we can start by picking, let's say, this podium down here. You choose sort of the building program. We can say it's a commercial building. You choose sort of a basic cladding envelope system. Maybe it's limestone veneer.
Wow.
And a window to work.
And yeah, there's a bunch of options in there too.
Yeah.
There are. And I think sort of this is a theme for us here, that in this first version of this analysis, we've leaned really heavily towards making it as easy to get started as possible.
Yeah.
As it continues to develop over the next, 6 months, we're going to try to add a lot more of the transparency and customization that you're going to hear Ian emphasize a lot.
It's not bad though. I mean, I also don't want people should be watching this on YouTube, but people shouldn't be also thinking that it's so primitive where building type is only 3 options, or rather the envelope only has 3 options. There's, 30 there.
Yeah, there are, and yes. So I guess we've tried to sort of hit that compromise right now, and then we'll try to add more on the back end as we go.
Fascinating.
So I've now sort of selected the rest of this building. Let's just say it's a residential building. We can say glass fiber reinforced concrete rain screen, and we'll leave that at the window to wall ratio at 50%. And then we can say that it's mass timber. And then we can run the analysis. And the analysis takes 5 seconds or something like that to run. It's really fast. Wow. Again, sort of with this goal of letting you iterate and ideate as quickly as possible.
Amazing. And so the bars on the right, it says envelope structure enters MVP, and there's like red, there are different colors and percentages. Huh.
Yeah. So those colors don't mean anything. It's just to differentiate between them a little more easily.
Yep.
And you can also see right now we're sort of looking at the carbon, the embodied carbon over the entire site. You're also, of course, able to filter by building, and then, see that breakdown by building system.
It's pretty cool. Yeah.
So the colors don't mean anything, but is there a way to know, like, are we like really high in the carbon footprint compared to an average?
Yeah, actually, there's a spectrum bar at the bottom, but is there an average number that would be considered an average building that you would compare against?
Yeah, so it's a really good question, and it's sort of a primary difficulty with doing this analysis right now, is that we as a industry have been focused on the operational side really heavily for 20, 30 years. Mm-hmm. And so we have great baselines to work off of for operational carbon. Everywhere has regulations that you have to adhere to. There's like LEED and BREEAM are really well-developed, stuff like that. Embodied carbon is much newer. And so all of that stuff is sort of still developing. There's some regulations in some places. I think California has just mandated that you evaluate the embodied carbon, but sort of there's no number that you have to be under. And so right now...
Did you do your homework? Yes, I did. Okay, good.
Yeah, exactly. And I mean, to some extent that makes sense. Like, we have to start by measuring it and then go from there.
Yeah.
But it makes it really hard to say, like, okay, this is 8,450 tons of CO2e. That doesn't mean anything to me. Sort of the only way to get meaning out of it is to iterate and say, okay, if I make this mass timber, I can save 50%. Without knowing sort of whether those absolute numbers are good or not. It helps you, we think it still helps guide a lot of those early stage decisions.
Yeah.
Is there a way, because right now we're looking probably mostly at new construction, but is there a way to select maybe, I don't know, the podium or the bottom half of the building to be existing structure we're keeping and we're just adding on top of it? Because that would offset the carbon footprint as well, right?
Yeah, it's a really good question. It's something that we're sort of working on adding. I think there are kind of workarounds that you could do in Forma to do that. It's not super easy to do natively right now.
Yeah, things quickly become complex. I could very easily
Well, there's just so many variations and scenarios out there that it's probably very difficult to establish a software that accommodates all of those.
The machine learning aspect, I think it really, really intrigues me. Going back to that image, you have the Kermit the Frog who's doing a rough guess, and then you have the generative, parametric generative model, whatever you called it. And the same issues apply for smaller buildings as well, where you have this gap between basically just doing a guess based on your gut instinct and kind of what feels right. And then, or you could try and crunch some numbers, but sometimes when the numbers get crunched, you're missing, like you said, the real world information where buildings are complex, as you said, and there's just more that's not there. But the machine learning model, which kind of incorporates a little bit of both in a certain sense, is a great way to close that gap.
And I think that's sort of like, Ian is going to talk about Insight, which is this really easy to use software that gives you results sort of for the stuff that you've modeled. And we think that this machine learning solution is a big step towards closing that gap, but sort of looking forward, what we really need are these tools that create this like whole project carbon workflow that sort of lets you work truly iteratively. We know that sort of building design is not a linear process. Some parts of the building become much more detailed faster than others, stuff like that. And so looking forward, we really want to create this workflow that brings in people of different personas and sort of allows carbon to be considered throughout that entire design process.
Yep.
We've covered most of this, but what we think that this tool is really useful for is informing those early stage decisions, understanding the relative impact of different building forms and primary materials. We think it's useful for sort of goal setting. From day one, you can get these whole building embodied carbon predictions. And this is a little bit more abstract, but for starting the conversation, having a real numbers in front of you, real evidence, we hope makes it much easier to make carbon driving outcome of early stage design decisions.
Right. Yeah, the accessibility aspect of all of this is critical. If you zoom way out, just having the conversations, as you said, and having to be part of the design thinking, it needs to be accessible. Because architects, for better or for worse, are inundated with a million things, and it being easy to access is I think it's essential, actually. If it's not easy to access, it's really tough for offices to adopt any thinking about carbon without them going like an extra 10 miles in the marathon.
Yeah, I've talked about a lot of stuff that I care a lot about, but if there's one thing that I maybe can leave you guys with and the listeners with, it's that we created these tools with a lot of input from practitioners, from engineers and architects and sustainability specialists, and we are incredibly eager to sort of hear from you now and from listeners about sort of what they see these tools doing well and the holes that they sort of see remaining in these workflows.
Gotcha. Okay, cool. That reminds me, this is a sort of a random question. If folks listening have questions about the softwares and whatnot, we'll probably include in the notes an email or something they can use to access. I don't know if it would be your emails or your personal cell phone numbers, but something.
Be careful there. Yeah.
Something would be good,
Yeah.
I think. Yeah.
I mean, look, I tried to get you guys to give out your home addresses at the beginning, so I think it would only be fair. No, I mean, I'm very happy to give my email address and have people reach out to me directly. That would be great.
Okay.
Yep.
I think this is great, even for students. I actually had a project site as an architecture student a couple blocks away from the one we were just looking at. And I'm like, hey, even as a student, it would be really cool to put your study models in the site and try to understand the site from a more, not necessarily technical approach, but a more true approach besides just views and site size and neighboring building, in terms of really data that you could design from.
Yeah, absolutely. I'll say very quickly just how you can access Forma because it is new. It is available as part of the Autodesk AEC collection, so many people probably already have access to it. There's also standalone subscription and a free trial, and I believe free access for students. Okay. So, yeah.
All right, so no excuse, really.
It's way better than that stupid windrows diagram that no one cared about. I mean, it's really cool.
It's really cool, yeah.
Should we turn it over to Ian then? I think I've taken up more than my fair share of the time.
All right, Ian, you have 15 minutes. No, we got plenty of time. Yeah, let's learn about Insight.
All right, great. So Ellis has set the bar really high.
Yeah, really long at least.
Yeah. Okay, I'm just going to share my screen. I have a few different things I can go through here, but I'm going to start actually with just something Ellis said that gave me a good prompt. He made the comment that everybody knows what Revit is and Forma is new, which is a fairly accurate statement, but I would say more precisely, I'd say everybody knows of Revit, right? And many people know what it's mainly used for, like detailed design, documentation, rendering, things like that. But not everybody knows everything it does. Right, it's a massively complex tool, and one of the features in Revit that is actually a feature of Revit. It's its own product line, but it is actually a part of Revit. You can't buy it on its own. You just get it included with Revit. Is Insight, and so we often joke internally that it's one of the best features in Revit you never heard about, because there's just people are so overwhelmed with new technology and even just things like working in the cloud now and things like that. So I'm going to talk about Insight, and just to sort of pick up from where Ellis talked about, Forma is really optimized for early stage design. You saw like the mass modeling, the rapid feedback, the multiple different metrics, and just the great simplicity of it. Revit, of course, is optimized more for detailed design and documentation, but people don't know actually you can use it earlier on in the process. It's not as slick, it's more mechanical. Yeah. That's the way I would describe it, but you can absolutely do mass modeling in Revit and start to add more detail into it. And of course, you can use Forma and Revit. You can import a Forma model into Revit and sort of continue your journey there. And that link is getting better and better all the time. So I just wanted to kind of say that at the outset, just to sort of get the ball kind of rolling. So like the story with Insight is that actually it really is a part of Revit. And to sort of, before I'm going to get into a demo, but there's a few pieces to it that are worth breaking out so that we know what we're talking about here. Autodesk Insight as its own product line, its own brand, so to speak, has been around almost 10 years now. And there's really three main parts to it. These are all, again, part of Revit, part of your AEC collection subscription. The first part is building energy. The other part is solar analysis, and the other is lighting analysis. Now, the solar and lighting, they're kind of what I describe as a what you see is what you get type thing, right? Like for anyone who's not seen the visual, if you imagine what solar radiation on a building looks like, it's like a heat map. That's what it is, right? And it can be analyzed. The lighting analysis is interior daylight distribution and quality and things like glare and so on. So similarly, it can be visualized as a heat map, and you can get certain metrics from that, like the average daylight factor or things like annual sunlight exposure or spatial daylight autonomy, some quite advanced metrics around that. So these two things kind of, the solar is very similar to what Forma does. The lighting analysis picks up from where Ellis was talking about that vertical sky component, the kind of boundary condition to daylight. This is daylight inside the building, right? Gotcha. They've been around for a number of years. They haven't really fundamentally changed. We're not really actively developing them. They do what they say on the tin. A lot of people love them, particularly people who want to keep their analysis kind of within Revit. But the energy piece is really the piece that has been evolving rapidly over the years. It's the more challenging one because energy is such an abstract construct, where you can visualize daylight or solar. Visualizing energy is a very different beast, and don't get me started on that. Why that's challenging. But what we determined when Autodesk kind of entered the space a number of years ago was that, look, there's already a lot of tools out there for doing very advanced building energy simulation, mainly aimed at engineers that and sort of detailed design. What's really needed is something earlier in the process that provides guidance, is more directional, and doesn't just provide you with a number, but shows you with magnitudes. So these little scales that you see, it's showing the relative sensitivity of, increasing the glazing or reducing the glazing area, or changing the type, or, shifting the internal loads, or changing the efficiency of the HVAC system. So it's very interactive. It's what we call outcome driven. It's very interactive. It's backed by hard simulation data run on your model. And it's pretty innovative in that regard. It makes energy analysis more fun and visual, and you've got the traffic light system to see what's kind of good and bad and things like that.
The traffic light system meaning red, yellow, and green.
Right, exactly. Yeah. Like, because if I said to you the energy use intensity is 1, 2, 3, Is that good?
That wouldn't
Is
mean a whole lot.
three
Is it bad?
high? Is it low? Is it?
Exactly. And it all depends on where you are in the world, the building type and things like that. So yeah, benchmarks is a key feature in Insight that indicates, if you're at this level, you're doing good, you're trending towards, let's say, Architecture 2030 and things like that. So there's some benchmarks in there. So we really learned a lot about how to kind of not just repackage this type of complex analysis, but also run this analysis in a way that provided high accuracy with low precision, right? And so we'll get into that a little bit more later on. And this is what still exists today. So Autodesk Insight, what I'll call original flavor Autodesk Insight, is still available today. But we have been working on this very, very hard over the last number of years of what we call now next generation Autodesk Insight. And the short version is that we reached the limits of original Insight's technology, both how it was architected in the cloud and the simulation engines that it uses and things like that. And so a number of years ago, we went about completely rewriting Insight to support a couple of different things. The first was a much wider scope than just building energy, because the conversation has really moved on from just energy efficiency to carbon, and from operational carbon to embodied carbon or total carbon. So that's the first thing about Insight, is that it has a much greater scope. It can analyze from your Revit model. You can analyze both embodied and operational carbon from the same model. You can look at the different breakdowns and trade-offs. You can kind of visualize the hotspots and things like that. And it's backed by your Revit model data, material data from, as a starting point, from Building Transparency's EC3, and then also Energy Plus for whole building energy simulation. So it's making something very, very complex as simple as it can. Not quite as simple as Forma is making it, because it's intended for a little bit later in the process, but you'll see what I mean as we go.
Gotcha.
Yeah. And then the other big thing about Insight, one of the lessons that we learned from doing these various types of analyses over the years, is that there is no one right answer or one right or wrong way to run these types of analyses. It all depends on the project, your region, your preferences, the kind of questions you're asking and things like that. And so what we wanted to provide was a starting point for people with as broad a scope as possible, i.e. total carbon, but also for any of the data and the analysis that we're providing it in a very open and transparent way. In other words, there's no black box, nothing is hidden. When we show you like a total carbon metric or an embodied carbon metric, we show you how that's actually calculated. Up to a certain level, right? We're not showing you all the code and things like that, but all of this carbon stuff, there's just a lot of kind of ultimately simple math of aggregation and disaggregation and multiplication, division, and some ratios of things. And so you'll see as we get into the demo how we're able to capture that logic, so that not only can people understand what's behind this stuff, if they'd like to enhance it in any way or change it, they can. It's extensible. And that really allows people to get started with a kind of what we call a default overview dashboard, but then also start to create more custom metrics and factors to answer different questions at different stages in the process and so on.
Yep.
That's kind of it at sort of 50,000 feet.
That's a lot of information.
That's a lot, yeah.
Right.
Okay, cool. That makes sense. Gotcha.
What I want to try and do here is sort of give everybody a sense of how it works, and because how it works gives you a sense of what it does or what you can do with it. And so there's really, in the simplest terms, there's really three main steps. The first thing is you start in Revit with an architectural model. When I get into the demo, I'll talk about that a little bit more, about the range of architecture that it can support. And the first step is you need to create what we call the energy analytical model. It sounds scary, but it's actually not as complicated as it really is. It's basically a kind of a simple straw man takeoff of the key surfaces and volumes and materials of the building. If you look at that Revit model, it's got like wall thickness and detail and layer by layer materials. But for analysis, we basically just take off like the total area of that element, and is it a wall, is it a floor, is it a roof, and things like that.
Gotcha.
And of course, the way people model in Revit varies widely, and we've developed over the years a number of algorithms that can more intelligently automatically extract that analytical model that's needed for this analysis. And so that's the first step. There's a little bit of a learning curve with that. We find most architects that are able to understand Revit, basic Revit modeling, can learn it in about a morning, right? Once you understand, okay, I get the nature of this analytical model, I know what is roughly accurate enough, and then they can base their analysis on that. So once you've created that model, you send that model essentially to Insight. From here on in, it's in the cloud. So the data is uploaded to the cloud, the simulations and analyses are run in the cloud, and the results are collated and presented in what we call this overview dashboard, or the default dashboard. You'll also see a series of breakdowns of things like embodied carbon and operational carbon and so on. And that's enough to get everybody started, just to understand the full scope of what total carbon is or can be, and then so far as how we've defined it. But obviously that then allows people to start to create custom dashboards and metrics to address specific needs. So if you want to define the scope of your carbon to be different, if you just want to focus on embodied carbon, or you just want to focus on operational, or you want to focus on both, and let's say you want to include some aspect of carbon offsets with different rules of thumb, you can incorporate all that logic into Insight and effectively make your own analyses. Okay?
Yep.
Yeah.
So we're getting a little bit closer to the actual fun part, which will be a demo, right? So I'm actually going to walk you through these key steps. Okay. You'll actually see there's probably about 50 steps as I go, but these are the three main ones, right?
Yeah, gotcha.
To get kind of going with this. Okay, so I'll start in Revit. And when you think of Revit, you sort of think of a fairly typical, DD/CD stage model. It's very rich, it's very detailed. It's got like curtain walls and ceilings and all kinds of complex stuff going on. Even this view right now is filtered down just to the main architecture of the building. Mm-hmm. But what we'd like to point out here is, if I just get Revit to change this view, that's what we typically think of Revit as being. But here we go. I've got 3 different Revit models here that kind of represent a simplification of 3 stages in the design process, from very early stages with conceptual massing, very close to what Forma works at. And if you were to bring in a Forma model, it would be like that. Mm-hmm. Into something more schematic stages where, you're starting to maybe skin out the building a little bit, decide where the internal layout and where you want to maybe a bit of feature curtain walling and open spaces and some plain old windows, through to, you're at detailed design and you've got, your rich Revit model. So I always like to, people tend to think of Revit at this stage, but actually you don't just, a Revit model like that just doesn't appear. It evolves over, in some cases, many years, right?
Sure.
Yeah.
And so we really wanted to be able to provide this analysis from any of these stages. We always encourage, you always hear, do this type of analysis early and often, but really start wherever you're at and go from there. I would encourage that if you're learning this tool for the first time, the simpler you start, the simpler you'll understand how it works, and walk before you run. It's important to understand that. But once you have any of these models, or any mix of these models, you can mix massing and schematic. There's any number of like steps between these things. Like I could just put a single curtain wall on one of those faces if I wanted to, and analyze that and so on. But the first step is just to do what we call this create energy model. You'll see it's delete right now because there's one actually already there. And this is one aspect of Revit that is not Revit-y, as in it doesn't generate. It's a one-time on-demand creation of these spaces and surfaces. So I'll show you this model here in particular because it's kind of like the clearest one to show. But if I just show you the view of the analytical spaces, you'll see like this. And what it has done is it has identified discrete volumes of air basically inside the building that'll be heated and cooled separately from one another. And it's identified the paths of heat transfer between those two, right? So this is the basis of an energy simulation. And this is what we've used as a starting point for embodied carbon analysis as well, because it contains all of the material information in the model as well. So if I just take a look at, say, for example, that wall type in Revit. Remember, you don't have to add this at conceptual stages. I'm demoing this at a kind of a schematic kind of stage. You'll see that wall type, it's got like a timber frame, super high insulation. If I look at the layer by layer properties, you'll see there's layers in there with siding and an air gap and some EPS slab and some plasterboard. Just make it a little mental note of that. You'll see that appear later on. Not everybody adds this information to the Revit model. You don't have to. This information can be added on the Insight side. So the key with this is that you really can start from as little as a box in Revit with total defaults for everything. Mm-hmm. But then you can start to layer in decisions as you make it. So if you're decided on that timber frame, super insulated wall, you can then start to put that in Revit. And from then on, that will become what we call the baseline model that we analyze in Revit. So any questions on that analytical model piece before I leave Revit and get into
I guess one question is, so if we have a native Revit model and we click the generate energy model icon button, is there something we have to do? Do we have to input inputs, or does it automatically make assumptions or know those volumes that you were describing.
Okay, here's the total full disclosure thing, right? I will say, as much as I wish this was the opposite, I will say 9 times out of 10 when you do that, the first time you do it, it will fail. And what I mean by fail, it'll create something that you just, what is this? Right? And the reason for that is that every Revit model has a certain posture, right? That like there could be, the view might have the roof missing off it, or somebody just hasn't modeled the roof yet, or something like that. And so, but once you understand how the analytical model works, then you can very easily fix it. I mean, the alternative to this is manually authoring a completely separate model. That's what other sort of tools force you to do. Takes time. It takes some skill in learning how to do it. We've automated it so that you don't have to do that. You author a model. But what you really need to do is, the short version of it is, create a view that only contains the things in it that you want to analyze. Gotcha. Right? That's the first bit of advice I would give, is a little bit more to it than that. The other thing is, yes, there are some defaults, but if you just take Revit's own defaults, they're kind of neutral as far as the analysis is concerned until you learn the role they play, and then you can start to go in and override the materials, override maybe the HVAC systems or whatever it might be. You kind of learn incrementally. The model doesn't need to be perfectly watertight or anything like that. These are all kind of, that used to be the case, that is still the case depending on the mode you use Revit in. There's different modes and so on. But at the end of this, I'm going to provide some links to getting started with this, and there's a lot of different little, minute or two vignettes of how to do all of this. And I'd really recommend, you need to look at this. This is reasonably technical work. It's not, I wish it was the easy button, and it is a button. It's not that easy, right? You've got to understand the different elements that go into the analytical model. You got to understand some of those settings, like things like resolution settings and things like that. But like I said, a typical architect can learn this in a half a day or a day. They understand, I know architectural modeling. I know now what this algorithm needs to create this analytical model, and I know what good looks like there, and they can do that. So yeah, that's basically how that works.
Gotcha.
Okay. This analytical model thing, we could just spend the whole hour on that alone, but I'm gonna say, so once I have this point where I have this analytical model created, I can click on this analyze, and it will send it to the cloud. And depending on the size and model complexity, it could take anything from a couple of minutes for a very large, very complex model, maybe a few hours to actually run that initial analysis. Once you get that analysis, then you can sort of explore the results in real time, but it does take some time to do that initial processing. So I'm now going to jump into a browser and Insight. Sorry, David, you're going to say something?
No, I was just going to say, sort of, this is basically the step right after we hit upload and it processes, and now we're at the next step.
Exactly.
And
yeah.
It processes the same model.
It sends you an email saying, hey, the processing is happening. We'll let you know when it's complete, and click on it. It works a little bit like cloud rendering. I don't know if you've ever used cloud rendering in Revit. It's a little bit like that.
Gotcha.
We're always working to make that as efficient and fast as possible, and we try to run as detailed and accurate an analysis we can that's relevant to the stage. You got to remember, we're using cloud resources to do this, and ironically, we don't want to use so much cloud compute that it actually is offset by the actual amount of energy that you're trying to save and the thing. Right. So we try to be efficient with this, and we've developed all kinds of ways to run that efficiently and so on. But that's a little bit of inside baseball and how we there's a lot of stuff going on behind the scenes that you don't see,
I'm
right?
Sure.
Anyway, so now that we're in Insight, what you will see is this, what we call overview dashboard. It's the default dashboard. All of these ones that here, these are all ones that I've created myself. So if you use this for the first time, you won't see this. But that is that analytical model now in Insight, and the default dashboard. I'll just give you a little orientation about the key things. Insight is built on this concept of dashboards and cards. And so this is a dashboard. These are all individual cards. Notice this one is not editable because it is the default that we give everybody to start with. I'll get into custom dashboards later on, but you'll see different types of cards, like text cards. So just if you want to put a little notation on something, you can do that. You've got a 3D model view, of course, that can do different things. I can report different pieces of data or inputs or outputs from the model, like the building location, which I forgot to mention, that's something you set in Revit. The building type, the area of the building, that's the total floor area. You'll see this little thing, I'll come back to that later, called a factor. And then these things called metrics, right? This is really the key thing. A metric is any key outcome that you're basically targeting. So you'll see the key ones we provide here are total carbon, embodied carbon, and operational carbon. And if you actually hover over the little I buttons, you'll see a little explanation for what they are, and you'll see pretty classical kind of dashboard behavior if you want to see the breakdown between these things and what they break down. So you can see total is operational and embodied is all these different parts of the building and so on, right? So in that regard, no surprises in terms of the dashboard. It's what it does next is where it gets more sort of interesting and fun.
I'm already interested. But
right.
Yeah, let's continue.
Okay, so the first thing I'll show you is that, when we talk about this idea of openness and transparency and extensibility, right now we're just looking at this dashboard, total carbon. I can see what these things are. But if I go into this manage metrics button and I pick on, for example, total carbon, you'll see that it's got a name, a description, a unit type. See the display unit is kilograms, CO2e. Ellis talked about that earlier. And then you'll see this very simple formula, operational carbon plus embodied carbon. It really is at a level as simple as that. But you'll notice this little purple color coding, it's because that is another metric, right? So you've got two other metrics in here. It's just summing these two other metrics. So if I go back and look at what embodied carbon is, I'll see the formula for embodied carbon, and it's basically just summing the embodied carbon of the walls, the embodied carbon of the floors, the embodied carbon of the roofs. And we'll see later how we can dig into those more. And if you look at operational carbon, you'll see it's the annual operational carbon plus the annual operational carbon due to electricity, the annual operational carbon due to fossil fuel use, multiplied by the building lifespan. And notice the little green one there. That's because it's a factor, it's a variable, right? Yeah. Making sense so far?
Yeah. Yep.
So yeah, it's a little mathical and technical and things like that, but we're trying to just strike that balance between simplicity, but also transparency and extensibility. And you will see that actually it's not as complicated as it might sound. It can get very complicated, but it doesn't have to be. So the other thing to notice here is the fact I wanted to point out this thing that we call a factor, right? And the big thing, if you're talking about total carbon, i.e. embodied plus operational, the single biggest factor in that equation is not your insulation, not your orientation, none of those things. It's the period of time that you're considering the total carbon scope to be. And that's why we place it on this default dashboard. This is really just educational and to get the conversation going. But you'll see right now, the lifespan is 1 year, and you'll see that there's a lot more embodied carbon than there is operational carbon. But if I press this drop down and I pick, let's say, a medium building lifespan of 15 years, or 25 years, you'll see now we've got a lot more operational carbon than we do embodied carbon. Now, that's such a simple concept, but if anyone's doing any analysis or anyone's talking about carbon or carbon targets or what we're targeting for carbon, you really need to be clear on what your kind of scope in terms of time frame is. There's more nuanced version of whole life carbon that get into things like replacing building elements over time and things like that. That you can create insights that cover that. We've got some custom dashboards that do that, but we're trying to give people the simplest possible starting point to understand the basic concepts and then allow them to enhance their analyses and as their learning enhances as well. Is that okay?
Yeah. Yep.
Yeah, but that simple principle of real-time feedback of, just being able to simply demonstrate that. Again, nothing remarkable in dashboard world, but it's just the sort of relative simplicity that we do this with and the data that we have access to that we do that. Okay, the next piece I'm going to look at, so we've looked at total carbon. We can see this dashboard is pretty self-explanatory in terms of the total, the embodied, and the operational. But one key thing that people want to dig into is what we call the embodied carbon details. So this brings us into a slightly different looking dashboard where we can actually see here, you've got the model view and you've got this heat map based view of where the carbon in the building is going. We've got different ways we can look at it, like by construction, by category, even by design stage or level of detail if we wanted to. And equally, you can look at things like the total embodied carbon by the category, total embodied carbon by the construction type, total embodied carbon by the material, and then total carbon intensity, right? So there's different high level graphics that help people understand overall where the embodied carbon is going. But of course, all of this calculation is based on whatever quantities were in the model, like your floor area, your slab area, your roof area, that information, as well as each of those elements' material properties. So the example I showed earlier on in Revit was the exterior wall, right, the basic timber frame wall. You remember I showed you those layers. So the fact that that model actually contained that was this timber frame, super high insulation, we have the siding, we have an air gap, we have, which obviously has zero carbon, we have insulation and we have plasterboard. There's an embodied carbon assigned to each of these. Now, when you use this for the first time, there'll be a lot of little warning marks saying, hey, you need to set these. And the setting, the database that we ship with Insight out of the box is basically a copy of the EC3 database from Building Transparency. It's a good starting point, but we definitely encourage people to look into each element and add their own, right? You can absolutely use that as a great starting point, but you can change those things. But if you want to do that, you can open up a whole search engine, and this is the database. So if we wanted to look at, I don't know what I picked there, but let's say it was insulation. You'll see this is a copy of all the insulations that are in the EC3 database. You can add your own, and you can see the different range of embodied carbon of insulation and so on, which is a good one. I think that insulation is a good one because there's a really good total carbon question there where you can start adding insulation to the building, but at what point are you paying more in embodied carbon than you are in saving in operational carbon, right? So that's just a little orientation on the embodied carbon breakdown, which is kind of its own thing because, as Ellis mentioned, there's no real rocket science to embodied carbon. It's quantities and elements and materials times embodied carbon factors. It gets aggregated, and you can look at different trade-offs. We could look at the impact of different, let's say in that case, insulation levels, concrete, steel, whatever it might be. Note that this, as a starting point, is based purely on what I'll call the architecture of the model, i.e. it's got the slabs, it's got the floors, it's got the walls, roofs, the glazing. But what it doesn't have is things like columns and beams and MEP and things like that. That's something that we plan to add later with a different mechanism. But at early stages, you don't have that information anyway. True. But you can start to incorporate it in rules of thumb. And I'm going to show you how some of those can be done as part of a custom insight, given that everybody has their own rules of thumb for these things. Is that okay?
Yep, fascinating.
This for me is where the real fun begins, where we get to go in and start to do some custom metrics and dashboards. So the first thing I'm gonna do this completely from scratch. I'm gonna create a new one, Second Studio, and it'll create a blank dashboard. And if I go and edit dashboard, I can get this card library. I'm just gonna add just one of each just to get started. I'm not gonna do anything super intelligent here. I'm just going to show you mainly how it works. But notice the dashboard. I can lay these things out any way I want. Well, not quite any way I want. They follow a kind of a structure. We're working on more kind of flexibility in this over time. But yeah, once I've got them in place now, this bar chart, I'm going to connect to, let's say, operational carbon, right? I'm a mechanical engineer. I'm an energy guy, right? So it's like this is my jam. And so we've got the operational carbon here. You can see the operational carbon due to electricity and fossil fuels. So you can see the electricity is the major driver here. If we were to go back to Revit, change the mechanical system to all electric, you'd see that kind of thing and how it is different. But this drop down here is where I can say pick one of the factors that I have, right? And so, for example, the electricity emissions rate is a key one, right? So wherever you are in the world, wherever you are in the States, say your electricity is sourced from the grid, and for example, the grid is dirtier in some places than it is in others. So that has a big impact on the overall operational carbon. Like your building uses a certain amount of a certain type of energy, but based on electricity, it will vary that. So sorry, I think I have another one here that I created. Grid carbon intensity. There we go. That's a better one. I think there's more range of values here. Yeah, and so you'll see, for example, there's a current worst case scenario. You've got a current statewide average, or you've got a future state. Now, this is just one I created myself based on that. And so if you see that, I can change these things. I can make a little note here, like that this data is from the Energy Information Administration, www. I can attach a little notation to this information. And this is really important because so much of this sort of carbon analysis has so many, not only rules of thumb, but also you're sourcing information from different places. And so we wanted to be able to capture some of that logic in here as well. Anyway, you get the basics idea of creating a custom dashboard, right? But once I do that, I'll just continue with save. So yeah, it deleted the ones that I didn't use. And so now that it's in sort of explore mode, I can jump through this, and I'm just realizing this one obviously isn't the one that's connected to that. I'll need to go back and change this. There we go, that one. I'm constantly messing with this, so I break it from time to time. So now you'll see that when we change the grid carbon coefficients, you'll see the impact on the total operational carbon, right? Equally, if we were to go back here and say, what's the role of building lifespan? I could go in and I'll add another drop down, and I could set that to be the building lifespan. It's this one. Notice I've got a duplicate of that for some reason.
So when you're adding these, I don't know what you call them, kind of like cards, right?
Right.
And then there's a palette where you can select from like 100 different cards.
Right.
Some of those are out of the box, and some of those are ones that you've created.
Exactly. And that's exactly what I'm going to show you now, right? So this is just to show that if I wanted to sit and have a conversation with a client purely about the operational carbon and point out the fact that the assumption we make on what the grid carbon efficient intensity is today and what it might be in the future and things like that, there's a whole conversation there to be had there. This is the assumption we're going to make. And we're also going to say, yeah, we're going to use 25 years. It's just you can have a very focused conversation about that. But then, of course, you can go and look into other things, right? So the thing I wanted to show you here was how, what you mentioned there, David, was, yes, under the hood, there are like some standard data that's come out of the box, but then you can create your own, right? So this is where we get into this idea of managing metrics. And so, for example, I was showing you earlier on, this is where total carbon is defined as that plus that. But the one I was looking at there was my own version of total operational carbon, where I've defined this way, right? Annual electricity minus annual renewable energy and so on. I've built a whole dashboard around this, and you'll notice the little color coding. This is the menu. Let me go into the edit mode so you can see it a bit more clearly. I can build a formula that defines a metric from basically other metrics, right? That we've already got, either from the system or ones that I've created. I can create it from any of the analysis results, like total annual energy or embodied carbon in the ceilings or whatever it might be. I can also use certain model data, like I could divide it by the building floor area, I could divide it by the volume, I can do different things there. And equally, the really fun one though is what we call a factor. A factor is a variable, right? It's something that we want to explore the impact of. And so this is where you can see the building lifespan and the grid carbon intensity. Just by adding that into the formula is the reason why when I vary these things, that value is changing. It's very simple math, right? But in one place, it's this is one of the things we learned, was that a lot of people are doing this type of work in Excel. Like
I was
Excel
just going to say
the other BIM tool, right?
Exactly.
There's nothing wrong with that, but it's, you know, the thing with Excel is that the only person who understands it is the person who built the spreadsheet, and it's easily to break and stuff, and it's not really connected to but you got to export data from your BIM into a spreadsheet and so on. And so even that lent itself to an opportunity to make it even simpler and more connected. The other thing as well is the fact that this also has access to all of the simulation data, the embodied carbon data, and things like that. It'd be a fairly complicated spreadsheet if you built this thing yourself, and lots of people are doing that, but they have one certain scope that it works for, and it doesn't really scale beyond those things, or it reaches its limits and things like that. So one little thing I forgot to mention as well is to talk about factors. So if you look at building lifespan there, and we look at, I think this is my version of building lifespan, and I can go in here and I can edit this. So not only can I edit the fact that there's a variable there called building lifespan, I can also edit, you know, the actual values in it. So if I wanted to add an additional step in that analysis and to, let's say, 50 years, and that I save that, should be no surprise. You see now 50 years, right? And so you can see the different time frames. So you can do that for all kinds of what we call simple factors that, you know, have a variable. And you'd be amazed again how many, when you're doing carbon analysis, how many of these key metrics are really just simple math of X plus Y divided by Z and things like that. And people don't necessarily understand that. Like the best example I often give is energy use intensity. You guys know what that is? Energy
use intensity?
Right, EUI.
I would imagine how much energy is being used at a given moment in time or per hour.
It's actually the total annual building energy divided by its area, right?
Oh, okay.
And so it's like an MPG for a car, right? So it's actually over the whole year.
Gotcha.
And what's interesting about that is a lot of tools will just, your EUI equals X. People often don't understand, well, what is that? And so just to sort of demonstrate that, if you want to look at what energy use intensity is, and I'm pretty sure I have it in here somewhere, there we go. You'll see it's annual total energy divided by the net conditioned floor area. And this is an example of where, you know, well, how did you count the floor area? When you're at massing stages, you might be overestimating it. You're at detail stages, you've got it more accurate. You could put in a fudge factor here if you wanted to, of, you know, well, we know the model is overestimating, so we'll divide it by a certain amount. And so you can actually, more flexibility, more transparency in what these things relate to, but also more flexibility in how they're actually defined.
Yeah.
Okay. So then just to sort of close this out, just to give you some examples of the kind of things you can do with this dashboard, and I'm always playing with this, but one of the ones I like is that when I send a model from Revit and analyze it, one of the things I want to do is just look at all of the model data. So this is like the building area, the net conditioned area, the area of exterior walls, underground walls, there's none, interior walls, exterior openings. It breaks it down piece by piece. I'm able to calculate the overall window to wall ratio, the surface to volume ratio. They are all custom. Some of them are custom metrics. Some of these are standard metrics and so on. So that dashboard is something that I use as sort of a QA/QC to look at a model, right?
Yeah, yeah.
My favorite example, actually, there's one other on the embodied carbon, and this is a great example of how we can start to tie these different analyses together. This is a similar thing, but breaking down embodied carbon. So you can see the embodied carbon of the slab on grade, the roofs, the raised floors, interior walls, and so on. But if you look at that if you think of a Revit model and you think of the analytical model, there's no accounting for the interior, right? Mm-hmm. The fixtures and fittings. If you look at C-Scale and you look at the documentation, they have some rules of thumb for the interior fit out where they say a low carbon or best practice. So I literally just took the documentation from C-Scale and I created a custom metric called interior. And I said, hey, X equals Y and so on. And now I can see the impact of adding the interior into the equation, right? So this way I can start with an analysis and I can actually add, because whenever you do the analysis, there's always this like what if or what about question.
Right.
And if the tool doesn't do it out of the box, you're kind of out of luck, right? You got to go and find another tool or something like that. This is our whole principle of openness and extensibility, where we can provide the transparency on what's happening. Yes, it's a little complicated, but we don't want to hide that. It is complicated, right? There's no getting away with that. We don't expect every user to get under the hood, but people who are diving deeper into carbon, we're trying to make that journey as easy as possible for them to capture those kinds of rules of thumb, connect them together, and then reuse them on projects and so on. So that's a good example of just a simple little rule of thumb you can incorporate for the embodied carbon interiors. Again, I'm the energy guy. This is my personal favorite for the renewables. What is the effect of adding photovoltaic to the building? Again, at very early stages, you start to ask these questions about, about things. So if we were to say a 25-year building life and we can enter the cost per unit of electricity, the price of carbon offsets. So, this is a combination of both renewable PV and carbon offsets. You can spend anything from $1 or $2 on a carbon offset to like $150, $200 on a carbon offset. Mm-hmm. They're not the flavor of the month at the moment because there's been a lot of things in the news about their ineffectiveness and things like that. They are still a tool, and the more you pay, the higher quality you get. Mm-hmm. You can't pay for all of your sins, but it is a viable thing. Clients regularly ask, well, how much should we pay for our carbon offsets? If this project is going to be X total carbon, how much sin do I need to pay for to offset that and things like that? And so you can very easily say, showing that depending on the price you put on carbon and depending on, and this is really where you get in the percentage of roof you use towards photovoltaic, the level of efficiency you use, things like, are there any incentives for photovoltaic, like 30% capital cost savings? I've built a little dashboard here that takes really nothing but a set of simple rules of thumb that take the roof area, the incident solar radiation on the roof, the photovoltaic efficiency. There's a bit to it, but I'm very easily able to incorporate that kind of logic into this dashboard, take the annual energy produced by the simulation and able to understand this total carbon offset cost. So yeah, that just gives a good idea of the kinds of things you can do with Insight, and mainly the way it works was mainly what I was trying to communicate, but then give you some clues as to kinds of things you can do with it. And what we've seen people taking in all kinds of interesting directions, and we're learning from that and what we can make easier and things like that.
Yeah, I can see how if you would do this in an Excel sheet, it's certainly possible, but
but why would you do that?
I mean, that's the fascinating thing about Insight and even in Forma as well is so much of what you guys have to do is to look at so many variables and pieces of information and then figure out a way to make it real, but also digestible and also applicable to different use cases and different locations and different everything.
Right.
So I like the idea that the output of what we're seeing in these dashboards is very simple and customizable, but you can customize it to be almost anything. So it's fascinating.
Yeah, it's back to the thing is that there is no one right answer.
Yeah.
There's no one right or wrong way to analyze total carbon. This is where we get into this thing about accuracy and precision and things like that, and how accurate is it? And it's like, well, all of these models at the end of the day are imperfectly perfect, right? Meaning that they're imperfect, but they're perfect for the job you're trying to do right now, which is at an early stage. I just want to know what percentage of roof I should use for PV and how much I can get the client to pay for carbon offsets, right? I mean, then it's perfect, right? You don't need anything more than that. And so, yeah, the fact that there's so many different questions, so many different ways to look at this data, and that sure, you can use Excel or Power BI or other, but they are all complicated tools, right? And what we wanted to be able to do was create a tool that an average architect or engineer can get into with reasonable ease and start to understand how this type of analysis, like just what is total carbon, for example. First use case of this is what is total carbon. Yeah. Second use case is getting started with that type of analysis and understanding it. And then as Ellis said, the thing we really want to encourage is conversations between people, like between architect and client or architect and engineer. What are you assuming about this? Do you have a good rule of thumb for that? Do you have some even better data for that? And this is a place that it can be captured in one place.
Yeah, that's fantastic.
I think for both Ian and I, starting off by saying sort of one of the things we love about our job is that we get to listen to practitioners. We've done the vast majority of the talking here. So I'd be really curious, Ian and I both come at this from engineering backgrounds. I'm really curious to sort of hear what you guys see as the challenges of incorporating sort of analysis generally into a workflow that I think a lot of people get into because they prize sort of the artistic and the design side of it so much.
Mm-hmm. Yeah, it's a really, really good question. And I will also use this opportunity to say that I encourage our listeners to contact you guys through the contact information in the episode notes to voice your thoughts and opinions and questions and whatever else. That's why I keep saying that for me, the challenge is just access to one, knowing about the tools, which Ian had highlighted, and then understanding that it's not an intimidating thing and getting understanding of how they get used roughly, but making that entire process I've described being very smooth and easy. And that's probably one of the things I'm most impressed with is that I can feel and sense that the amount of work it takes to take a very diverse set of information that could go in many different directions and then package it into these platforms and softwares that you're describing and showing in a manner that makes it kind of, kid friendly for architects is quite the challenge. But I think that is the hurdle for architects, right? I think when you get to larger offices, it becomes a lot easier because you have more people on a project and you can dedicate someone and say, okay, you're going to spend, either you are an architect, a traditional architect, but you're going to spend half a day, an hour or a day, whatever it is, learning these tools, and we're going to do this. Or you might have someone in the office who's dedicated to these kinds of tasks office-wide. But I think for offices who are not that big and can't afford having someone spend that much time, on a project, it's basically about having those platforms feel friendly and make you understand that you're not gonna be an expert in the end. Like, you're using these tools to help you understand how you can do better at your design job, but you're not an energy analyst. You're not, you're not the expert in those things. You just you have to dip your toes into them to understand them and get comfortable with them to a point where maybe further down in your career and the projects, you would be more interested and you would have a better understanding of what those things are rather than, seeing them from a very scary eye and feel like they're very technical and we're never going to get there, so why bother? And the platforms are complicated and we can't communicate to our clients because we don't know where to start and how to start. So kind of having those little tools available, I think is super important for us to feel more comfortable thinking about those things, also talking about those things with clients who might not even understand any of it. Sometimes clients don't even understand floor plans, so good luck talking to them about energy and carbon charts,
footprint.
Everyone can understand.
But bar charts, color-coded things, diagram, like visuals, it comes down to how do you make the spreadsheet
exciting for people to actually look at and pay attention to, right?
That's a big part of it. I like the flexibility, because I can imagine as one becomes more comfortable, not just with the softwares, but with this topic in general, and you start sourcing data from different places, which, as you said, it's a really good point. It really depends on the project, where you're located, the different, kind of governing bodies that are where you are, and what you care about, what the client cares about, that it gives you the flexibility to put those in, and then you can go further into the rabbit hole if you want to, or if it calls for that, or you don't. Right. It's pretty impressive.
Yeah, I mean, the comment on the size of firm, I will say, what's been really interesting for us, given the fact that original Insight, when we're just talking about energy, was targeted at architects, what's been really interesting, we have seen firms at every scale use it, from very, very small to some of the biggest. And it's mainly just to do with that accessibility. It's there in Revit, you already have it. We try to keep the barriers low as possible, and it provides you with something useful. No, it's not every analysis you need. No, it's not going to do your lead documentation for you. But what we've seen is that it allows people to, particularly students as well, understand, oh, this is a thing. I can understand this a little bit more. I can speak to this subject a bit more. And then I might speak to my colleague about it. They might teach me something, or I might teach them. And then we grow enough confidence to maybe bring in a specialist. And the specialist can just have a better conversation. And going forward, one of the things we really want to be able to do is we can see, those experts in the corner of the office are able to curate the way they believe analysis should be run at different stages in the process for different project types, for different firms. And that knowledge can be democratized a lot more easily is really the reason why we're going down this path.
Do you freelance on the side, Ian, as a consultant for offices? I guarantee there's listeners thinking that exact question. Like, oh, just hire him. Like, why would I?
I wish I could if I had the time. No.
Yeah, I'm sure. Sure. I also wanted to quickly touch on the subject of precision and accuracy, which we've talked about before a little bit. For someone like me, for example, who would be coming into all of this more at the novice end of the spectrum, I wouldn't be questioning. That would not be a question for me. I would say this is great. It gives me a really good place to start, and I can get more into the details as I move forward, over the months or the years or whatever it is. But I guess for some folks, they would be wondering about the accuracy. Is what you said regarding that, essentially it's an equation, so it depends on what you're putting into the equation, I suppose.
Yeah, I mean, well, first of all, David, that's absolutely the right attitude to approach any tool with. You got to walk before you run. Don't trust anything blindly. The point is that, look under the hood and these kinds of things. But the biggest criticism we get of this type of tool is the old garbage in, garbage out.
Ego. Yeah.
And it's a very real thing. But I think that's a result of people who think that, hey, I'm going to put some data in and I expect this thing to be right, and they're not taking the human is not taking responsibility there for what they do. If you're getting a number that you don't understand or where it came from, you maybe shouldn't be presenting in a design team meeting, right? You should ask somebody else about it. But the thing is, if you really do look under the hood and start to understand, particularly take something like embodied carbon, again, it's not rocket science, right? It's very tricky because there's a lot of uncertainty early on in the design process. There's bits of missing information and things like that, but that still doesn't stop you having a conversation. So accuracy in that case there is not really numerical accuracy, it's directional. We want to have a conversation about embodied carbon. This is, like as Ellis said, a typical building's embodied carbon might be 500 kilograms per meter squared. We're targeting 300. Because we're thinking of these things. I mean, that's a very easy conversation. That's very accurate, right? It's not very precise, but it's accurate. But then as you get further into the process, and particularly as you get into things like energy simulation, there are so many inputs and algorithms. Like the Energy Plus engine is like 20 million lines of code in it or something like that. It's incredibly complex building physics and so on. And there's any number of variables that will influence the outcome. But if anyone who's done any of this analysis before knows and understands the major inputs to those things and how they account for, within a plus or minus 10% sort of accuracy, you can very quickly build confidence with these things, because you're not predicting the absolute energy, you're predicting a relative energy, and you can really only predict the absolute when you get into the building operations and you understand the occupancy and you understand set points and things like that, but unfortunately, conceptually, people get stuck with that. I often throw the example of how accurate is a napkin sketch, right? It's accurate because it gives me a sense of, you're thinking of something square, and I'm, again, engineer describing geometry. It's a square, it's a rectangle, it's a circle, it's a sail-shaped building. That points us in the right direction. Well, these types of analyses from early stage fulfill the same purpose. They're accurate, but they're not very precise, and you're responsible for the precision, right? Because once you understand that, you can start to flesh out more detail in a certain area. And if a client asks for, well, what's the role of renewables, or what's the role of all electric HVAC? Well, then that's where you add the precision. Meanwhile, the rest is context, right?
Yeah. And it also reminds me back to Ellis's early point of when you're at the beginning of a project, you're making kind of basic not basic, but
premature.
Not premature, but like, I also use the word basic. Basic, big decisions, but those decisions really dictate the direction and can really have a huge impact numerically, if with all those things we're talking about in the end. At that early stage, it's really quite fascinating. The thing I like too about all this conversation and the way you guys think about the software is there's a very strong sense of forward momentum to it. It's not like, here's data, deal with it. It's here's to how do we make it actionable? How do we have it be outcome driven? There is like some key kind of concepts within the programs which are incredibly powerful. So that being said, what are some of the things that you two as individuals are looking forward to the most for these particular softwares, or just in general in this conversation?
I just want to say that's a great one. We talked about accuracy and precision. We are actually talking about accuracy and precision relative to a moving target. So I mean, I think I've spoken enough about the Insight side. Ellis, you want to talk about that sort of super early conceptual stage mode of that, and where we're going with Forma?
Yeah, I think there's sort of interesting places that we're moving with Forma generally, where we're really working to both broaden its view to include a lot of that terrain, landscaping, sort of more holistic site design elements, and add detail level to create a better bridge between sort of what you would typically use Forma for, the stuff we were showing off, and getting closer to more what most people would use Revit for.
Gotcha.
And then I think for the carbon analysis specifically, like I said, we're sort of at the beginning of caring and measuring embodied carbon.
Yeah.
And so a lot of both the data that this model is trained on is going to become more easily accessible. It's going to become better and more consistent, which will allow us to more easily create better predictive models like that. And on, again, sort of the other half of the equation, we as an industry are going to align more and more on sort of the carbon intensity side of things, which will make it much easier to compare between designs. It'll make it much easier to sort of get those answers that you're looking for. Is this good? Which is a really fair question that right now is really hard to answer.
Yeah, that's well said. That's well said. Ian, any general thoughts on the future of with energy, carbon, and all of these things?
Yeah, well, I mean, we certainly have pretty clear priorities of where we're focusing next. I mean, one of the key things is to make it easier to share all those things. A key one is expanding the access to data, which we're looking to an initiative called the AEC data model at Autodesk to get at. So you can incorporate those structural beams and columns, MEP elements at a higher level of detail if you wish. But then we're also, Ellis touched on how AI will get better because the more structured data we have, and that's one of the things Insight does, it helps you structure the data around this, the better those analyses will get. But I just want to give a different perspective, is that we're also tracking the industry and supporting the industry quite a lot as well. One thing I forgot to mention relative to Insight is the ability to export to the AIA 2030 commitment and the DDX. That's built into Insight. That's something that we have sponsored the AA for many years in developing that API that we can use that. They themselves are expanding the DDX to incorporate more data for carbon. And so there's things like industry initiatives from the Carbon Leadership Forum around the ECHO schema, the Embodied Carbon Harmonization and Optimization schema, so that there's a more standardized way to actually break carbon down, which will, again, give us more structured data. So all those initiatives around more data, more structured data is going to heavily start to shift more capabilities towards the AI, the likes of the AI that Ellis was showing earlier on. There's still always going to be a need for what I'll call classic traditional math, right? And simulation engines, long-running simulation engines. But the main thing for us as well is just user experience. I mean, how do people find the workflow? We're looking at making improvements to that Revit analytical model piece and to how people interact with these dashboards and what elements they need to tell storytelling better. So we're not short of stuff to do. It's very much driven by how these tools are received and how people use them, and they use them for interesting things. They use them for things we didn't think they were going to use them for. And we learn from that all the time.
That's really cool. Well, I know we're just past the hour here, but everything you've talked about really also, for me, makes me very interested to revisit this conversation to see where we're all headed in, the 5-10 year timeline with the way also the computers are evolving in AI and machine learning. It's going to be super interesting. It's going to be really interesting. Yeah.
Absolutely.
But thank you so much for making the time to really talk through the details of this, your kind of philosophies on it, and all aspects of the bigger topic and the specifics of the software. I think it was super eye-opening, interesting, and for sure now at least people know about. They know the Insight's there. It's there in Revit. Yeah, so thank you both.
Thank you.
Thank you very much for having us.
Hi everyone, thanks for watching this video on YouTube. If you like what we're doing, then please support our show by hitting that subscribe button.
You can also find us on most of the social media, Facebook, Twitter, and Instagram. We're mostly on Instagram. And you can reach out to the hotline, 213-222-6950. You can send a text message or leave a voicemail if you have any reaction to this recording, any questions you might have, or guest suggestion, feel free to send it our way.
Cool. Thank you for watching and see you next week.
Thanks.
Bye.
Bye-bye.